Yes, George, can you hear my voice?
Yes.
Okay, so today we are going to discuss a very important portion, which is buffer solution. So,
Mm-hmm.
buffer solution, do you know what is buffer solution? Have you ever heard about that?
I've heard the term buffer, but not exactly buffer solution. I did hear it sometime before, though.
Okay, fine then. Okay, so buffer solution is something, it is a kind of solution that has the ability to resist any change in pH. So whenever you are adding a small amount of acid, whenever you are adding a small amount of base in a particular solution, so it is not changing its pH. But remember,
Mm-hmm.
you always have to add only small amount of acid in it. You always have to put a small amount of base in it. Okay, so we can
Mm-hmm.
say that it is a kind of solution which resists any change in pH when we add small amount of acid or small amount of base. But yes, if you put a high amount of acid or high amount of base in it, then definitely pH will get changed. Okay,
Mm-hmm.
so, if I talk about this buffer solution, so it's a kind of solution which resists any change in pH. pH means what? Yes,
pH means
potential of
basically,
hydrogen, right? You can say
yeah.
power of hydrogen, right? So pH on addition of small amount of base or acid. But remember, the important thing is small amount. You just can't put a high amount or large amount of acid or base in it, because if you take large amount or of acid or base, then definitely pH will get changed. Find
Mm-hmm.
that.
Yep.
Okay, so now you should know one thing. There are types of the buffer solution. So actually we have two type of buffer solution. So first we have the acidic buffer, second we have the basic buffer. Okay, so first one is acidic buffer and second one is basic buffer. Always remember, whenever you are trying to make buffer solution, okay, so it is made up of two things. Remember, first you always have to take a salt of weak acid, okay,
Mm-hmm.
and a weak base. So remember, whenever I talk about the this buffer solution, if I talk about only a single substance, like buffer
Mm-hmm.
solution is a acidic buffer or basic buffer, but there is a different category. If I say you are making a buffer solution of only single substance, then you have to take only weak acid and a weak base. Okay,
Mm-hmm.
but if you are trying to make a acidic buffer or a basic buffer, then you have to remember two things. First, you have to take a mixture, and in this mixture, if you are taking an acidic buffer, so you have to take first thing weak acid, and you have to take a salt of weak acid and a strong base.
Mm-hmm.
Okay, you know very well salt is made up of acid and base, isn't it?
Yeah.
So
Mm-hmm.
if you are trying to make a acidic buffer, then you have to take a salt which is made up of weak acid and a strong base. Okay,
Mm-hmm. Yes.
so if I'm trying to make acidic buffer, so it is made up of a mixture, and mixture of what? So as I said, mixture of, first you have to take a separate weak acid, simple, and second is salt. But I told you what is the condition for the salt. Salt is made up of what? So salt is
Strong
made up
base.
of, yes, a weak acid
Maybe acid.
and a strong base. Okay, so this is how you can prepare your acidic buffer, strong base. So can you tell me one example for that?
Sure. So let me finish writing that.
I guess it will be difficult for you. So I'm telling you, acidic acid. Just tell me, acidic acid is a weak acid or a weak base?
It's a weak acid.
Yes. So it means I have taken the weak acid. Now I have to
Mm-hmm.
take a salt, and salt should be made up of weak acid and a strong base, right? So
Yes.
can I take CH3COONA, sodium acetate,
Mm-hmm.
CH3COONA? Why? Because it is made up of that same acetic acid, which is the CH3COOH, and
Mm-hmm.
Na. Na means what? Like it's a strong base. It should be strong base, so we can say NaOH. So when CH3COOH and NaOH combines, so it is forming water, right? H from there, NOH from there. So it is
Mm-hmm.
forming H2O. H2O, we
Yep.
don't need H2O, but we are taking CH3CONA, right?
Mm-hmm.
So when you take mixture of both these things, so we will get the acidic buffer. Find that.
Mm-hmm.
Okay, so there is a formula, and like if you want to find out the pH of the acidic buffer, so there is a formula for that. pH is always equal to pKa plus log salt upon acid. Salt upon acid. Okay, so this is the formula for the pH. So this is how you can find out the acidic buffer, pH of acidic buffer. Okay, this is the
Mm-hmm.
pKa value will be given to you, and concentration of salt and acid will be given to you. Then I guess it would be easier for you to find out the pH. Okay, now the question is how this acidic buffer is working. What is the like mechanism? What is the buffer action? Okay, so I want to tell you something. Suppose if you have a weak acid like CH3COONA, yeah, you can say like CH3COOH, right? So
Yeah.
CH3COOH, so obviously it is in equilibrium. So when
Mm-hmm.
CH3COOH is in equilibrium, so obviously it is forming the ion CH3CO minus, and it is forming the H plus. Yes or no?
Mm-hmm. Yes.
Okay, okay. And now if and you also take a salt which is made up of weak acid and strong base, so that was the
Yep.
CCONA. So
Yeah.
but that salt is not in equilibrium. Salt is not equilibrium, so it is giving direct result. So now you have CH3CO minus and you have Na plus. So it means this first reaction is in equilibrium, but that is not in equilibrium, right?
Right.
We have CH3COH final solution. We also have ion. We have H plus. We have this ion and we have this. But we don't have this, right? Because it is already
Yep.
converted into that. It is not in equilibrium. Okay. So now, so all these two reaction are giving you a particular pH. Okay. But now, if you are trying to put small amount of acid in it, so we can say upon addition of small amount of acid, so if you are using a small acid into it, so of course that would give you the H plus ion, right? So
Mm-hmm.
if you add a small acid in it, H plus, so can you just see that in the
Yeah.
solution we will get the ion, we will have a such type
Mm-hmm.
of ion CH3CO minus. So
Mm-hmm.
H plus and CH3CO minus, so that H plus combined with this, so it will form what? So can I say it is forming the CH3COH, yes or no?
Yes.
Why? Because that H plus and that CH3CO is also going to form this acetic acid. So if you add a more H plus, then it is combining with that CH3CONA, and it is giving you the acetic acid, isn't it? So
Mm-hmm.
any new thing is formed? No,
Yeah.
no, there is no acid, there is no new form. Earlier you had CH3COH, and now after adding H plus you also now you have CH3COH. So don't you think it is the same thing?
Yeah, I know it's the same thing, but I mean, like when you reverse the reaction, that's how it
Yeah,
works out. It creates
quantity.
some.
Yeah, quantity is increasing.
Yeah.
So we are not seeing the quantity, but we are seeing the nature. We are seeing the quality. Is there any new thing which is getting formed here? No,
No new thing being formed.
no new thing. So that's why pH is not going to get changed. If you take one bottle of NaOH, or if you take three bottle of NaOH, pH remains the same. So
Mm-hmm.
pH doesn't depend upon the quantity. pH depends
Yeah.
upon the quality, what thing you are taking.
Mm-hmm.
Okay, so it means pH is not getting changed, right, by addition of small
Yep.
acid. So of course it
Mm-hmm.
is working as buffer solution, yes or no?
Yes.
Okay, now we can also add a base. So upon addition of a base, so just tell me, we have to put a high quantity of base or acid or very small amount?
Very small amounts.
Yep. So now if you are adding a small amount of base, so base will give you the OH minus ion, right? Okay.
Yep.
So now base is thinking to combine with anybody. So here we have all these things. We have CH, we have this, we have this, we have this, and we have also this. So see, we have also CH3COH. So this OH minus ion is combining with CH3COOH. So what will you get? So you will get CH3 COO minus and H plus from there and OH minus is from there. So it is forming H2O. So H2O is neutral and you are getting CH3CO minus. So it is already
Mm-hmm.
there in the solution, yes or no?
Yes.
So if it is already there in the solution, so is there any new thing which is getting formed here?
Nope.
No. So if there is no new thing, so pH will get changed or not?
The pH won't get changed.
If there is no new thing, so pH will get changed or not?
Not.
Not. So it means, so pH is constant, right?
Mm-hmm.
So that is the working of buffer solution, yes or no?
Yes.
Okay, so it is quite simple. This is what, this is the mechanism of buffer solution. This is how buffer solution work. Okay, so we can say that
Mm-hmm.
this is the action of buffer solution. I hope it is clear. Any single
Yep.
doubt here?
No doubt.
So we have discussed the acidic buffer or the basic buffer.
We discuss right now, for the most part, the acidic buffer.
Okay, so now can you tell me about the basic buffer, like how it can be formed?
So it can be formed mainly by the addition of a weak base and then by a salt, which has a weak base but a strong acid.
Yeah. So can we simply say that basic buffer is a mixture of, because it is basic, so as I told you, we have to take weak. So it is made up of a weak base and a salt of, yes, any guesses?
A salt of a weak base but a strong acid.
Yes, very well, very right. So a salt of weak base and a strong acid. Any example can you give?
Sure. Just give me one quick second. Let me just write that.
Okay, see, this is the weak base and this is the salt of weak base and a strong acid. Okay, can we
Mm-hmm.
take an
So,
example of wait a
would it be
second.
NH4Cl?
NH4 is very right, very correct. Okay, so here if I'm taking the ammonium hydroxide, NH4Cl is a
Mm-hmm.
salt, completely fine. And if I talk about the weak base, so for that you have to take weak base also. So can
Yep.
we say that NH4OH?
Mm-hmm.
NH4OH is a weak acid, I mean weak base. And if you're taking
Yep.
this salt, so salt would be NH4Cl. Why? Because this NH4Cl is made up of NH4OH and HCl. So HCl is a strong acid, as I said, and NH4OH is weak base, right? So
Mm-hmm.
so when they are combining, so H2 will be released. So it is forming NH4Cl here. So this is the salt and this is the acid. So now you have this basic buffer, right? Okay,
Yep.
so for the basic buffer, so what we need to find out, pH or POH?
We need to find the pOH.
So here, what is the formula of this POH? So as I discussed earlier, so it should be equal to pKb plus log salt upon base. So concentration of salt divided by base. Okay, so this is the formula for finding out the POH. So if you have the POH, so can you find out the pH?
Mm-hmm.
How?
By just setting up an equation by adding 14.
Yep. So we can say that POH plus pH, or you can say pH plus POH is it is equal to 14, right?
Mm-hmm.
Very simple.
Yep.
Okay. So I hope this thing is quite easy for you, right? It is quite
Yeah.
understandable.
Yeah. It's comprehensible.
So this is a buffer solution, right?
Mm-hmm.
Okay. So do I need to tell you about the action of buffer, basic buffer? Okay, I'm telling you. Although
Okay.
although it's quite easy. See, um, if you have a NH4OH, which is a weak base, so it is in equilibrium, and of course it is going to get ionized. So you will get NH4 plus and you will get OH minus. Okay, now and you also have the salt, right? NH4Cl.
Mm-hmm.
But
Yep.
salt is not in equilibrium, so it is directly giving the product, right? And it is not going back. It is
Yep.
completely irreversible. So you
Mm-hmm.
have NH4 plus and you have Cl minus. So you don't have right now this, but you have this, and also this, because the first reaction is in equilibrium. Now, so how can we define the buffer action? I mean, how can we explain that? So we have to take a small amount of acid, right? So
Mm-hmm.
if we take small amount of acid, so you have to take the small amount of acid means H plus, right? So okay,
Got it.
so you have the NH4OH, yes or no? This
Yes.
NH4OH. So this H plus is combining with NH4OH, and when it's combining with NH4OH, so do you know what is getting formed? So this, it is forming NH4 plus and OH and H. It is forming water. So water is neutral, so don't think about H2O. But can you see that NH4 plus and
Yep.
NH4 was already there in the solution? So any
Mm-hmm.
new thing is coming or not?
No new thing.
So if there is no new thing, so pH remains same or pH will get changed?
The pH remains the same, or in
Yes.
this case,
So
the
this is the,
POH.
yes, that is the action of basic buffer. Now what we
Mm-hmm.
have to add in this solution? Can we say upon addition of a small amount of base? Because we
Yeah.
have already checked with for the acid, and now you have to check with the help of a base. So upon addition of a small amount of base, so when you are adding small amount of base in it, then let's take OH, because base will give you the OH minus ion. Okay, so now in your solution all these things are present, right? So it is going to
Mm-hmm.
combine with this NH4 plus. So when you
Yep.
have this OH minus ion, so this is combining with the NH4 plus, and it is going to give rise NH4OH. So just tell me, NH4OH is getting formed. So in the solution there was already a NH4OH, yes or no?
Yes.
And now it is also forming NH4OH. So again
Mm-hmm.
a new thing is getting formed, or the or like not, or it is the
Not.
same. So there is
It's
no
not getting
new
formed.
things, only the
Mm-hmm.
quantity is getting increased, right? No
Mm-hmm.
new things, no new substance is getting formed. So it means pH will remain the same or getting change. So it will
pH will
remain the
remain the
same.
same.
So this is about the action of the buffer, and I hope buffer solution and its action is completely clear.
Yep.
Okay, so if I ask you one thing, like if you want to make a basic buffer, then what you have to take?
To make a basic buffer, you need to take something which is a weak base and also another substance which is a salt that's composed of a weak base but a strong acid.
Very good. Okay, and can you give me one example for that?
Sure. So, to take a weak base, you can maybe use NH3, and then to for a
NH3?
str
No, no, no. You don't have to take NH3. You have to take like ammonium hydroxide. Ammonium
oh, okay.
hydroxide and ammonium chloride. Ammonium hydroxide is what? That is a weak base, and ammonium
Yeah,
chloride is a salt. Weak base and
yeah.
strong acid. I
Hmm.
ask you the basic buffer, right?
Yeah.
So, okay, not NH3.
I tried to think of a different example, but
Okay,
NH3
okay.
is all I could come up with.
Okay, fine then. Okay, and if I ask you about the, okay, what is the pH formula for the acidic buffer? As I told
The
you.
pH formula for the acidic buffer is going to be pKa
Yep,
times the logarithm of a salt over its acid.
very good. And that salt divided by acid, so it's a concentration or something else?
Its concentration.
Yep. So it's a concentration of salt and acid. So I hope
Mm-hmm.
this buffer solution is completely clear to you. Any single doubt
Mm-hmm.
here in the buffer solution?
No doubt. I had some trial and error, but so far I'm good.
Okay. And okay, just the last thing. And buffer solution, like if you have an acidic buffer, so it is composed of how many things? How many
If
substances?
it's an acidic buffer, is composed of mainly two substances.
Yes. What these are?
That's going to mainly be a weak acid and a salt that is comprised of a weak acid but a strong base.
Very right, exactly. So I hope this buffer solution is clear, and it is all about the buffer. Okay, and now we
Mm-hmm.
will take the different topic. Okay, so it's done for the buffer.